Good morning and good evening to our participants, and thank you for joining us today. My name is Jessica Gordon, and I'm a Climate Policy Fellow at the California-China Climate Institute, and I'll be the facilitator for today's timely discussion on charting a course for China's power sector coal decarbonization. Before we get started, I'd like to offer just a few housekeeping notes. We are recording this event, and it will be available later on CCCI's website. This event is being simultaneously translated into Mandarin Chinese. So you can use the globe icon at the base of your screen, and then you can select either English or the Chinese channel for your preferred language. If you'd like to ask a question of one of our panelists during the audience Q&A portion of our event, please type your question into the Q&A function at the bottom of your screen, and we'll try to answer as many questions as we can live. Working in collaboration with the Center for Global Sustainability at the University of Maryland, over the course of the last year, we developed an analysis of a practical and feasible approach for China to begin to phase down small and poorly performing coal plants in the coming decade. The report, called A Decade of Action, a strategic approach to coal phase down for China, is now available on both the California-China Climate Institute and Center for Global Sustainability's website. We'll also put the link in the chat. We're excited to share the report findings with you today and to hear thoughts from our expert panelists. But before we shift to the presentation and discussion, I just want to take a moment to provide some brief context. Transitioning from coal to clean energy is essential for China to achieve carbon neutrality before 2060 and keep the global 1.5 degrees Celsius target within reach. Over the last year, China has released a series of policies that demonstrate its commitment to moving off coal. These promising plans call for China to strictly control new coal power during the 14th five-year plan and begin phasing down in the 15th five-year plan period, which is from 2026 to 2030. So while we have these strong policy statements on the ground, we're seeing two different opposing realities. On the one hand, China is still building new coal-fired power plants, and over 200 gigawatts are under development. On the other hand, China is building renewable energy at an unprecedented pace. This tension between coal and renewable energy to fuel China's development and the changing policy landscape provides an opening and an opportunity. As we were planning this research, there were several questions motivating us. We know that the sooner China, and frankly the rest of the world, reduces coal use, the better, and the easier it becomes to meet long-term carbon neutrality targets and stay within our planetary limits. But how do we turn these commitments into action? Or specifically, how can China practically begin to phase down coal? Where should the action start? And how can China complete this task in a way that considers equity and provincial differences? And finally, what are the benefits of this transition beyond climate mitigation? How can moving away from coal address water scarcity, air pollution, climate adaptation, and other social and environmental challenges that China needs to address along with its energy transition? These are some of the questions motivating our new report that you'll hear about momentarily. As we know, China likes to plan. And drawing on this strength, we are setting forth a methodology and a strategy for a feasible and practical coal phase down, a plan, as Dr. Cui will note, that is aligned with China's multiple policy goals and will lead to marked improvements in climate, well-being, and the environment. Now I'd like to turn it over to Dr. Raina Cui to hear about the key findings of the report. Dr. Cui is Assistant Research Professor and Co-Director for the China Program at the Center for Global Sustainability at the University of Maryland. She's an expert in global coal and fossil phase-out, climate and energy policies in China, and global and national integrated assessment modeling. Over to you, Dr. Cui.
Thank you, Jessica, for the introduction, and also thanks everyone for joining us today. Let me start sharing my screen. Hope it works for everyone to see. I'm gonna do the slide deck show. Great. So I'm going to start with a very short presentation about this new report. And before I start, I just want to give an acknowledgement to all the great work everyone on this author list has made to this work. I'm also very honored to present on behalf of the team today. So we are focusing in this research this very important decade. The 2020s is very critical for keeping the global 1.5 degree temperature target within reach, and also for all the individual countries to reach their long-term net zero target, including China. The action in this decade gonna set forth a good path for China to reach the long-term carbon neutrality before 2060. But as Jessica mentioned at her opening remarks, there are quote unquote competing near-term priorities in this decade that may be having some challenges for enhanced climate ambition. So on the one hand, China has committed to carbon emissions peaking before 2030, also a strict control of new coal during the 14th five-year plan, and the US-China Glasgow joint declaration opened the opportunity to make this phase down work during the 15th five-year plan happening at a faster pace. At the same time, the renewable target on solar and wind are very likely to pass the 1,200 gigawatt target set in the NDCs. At the same time, China also has increasingly emphasized the security and stability of this decade, especially in the context for meeting growing energy demand, and also to support a larger share of renewables onto the grid. So coal is remaining to be a very important fuel in China's energy system, where the more efficient, flexible, and also clean use of coal has been promoted in the recent policy languages. So with the recent trend, also Jessica mentioned at the beginning, we see increasing total coal consumption, increasing coal fleet, and that trend may continue in this decade. We really need to ask whether and how China can enable a feasible near-term coal phase down while also balancing all the other national priorities. So in this report, we want to explore what are the full retirement potential in this decade by fully utilizing the existing policy tools we have within this 5-year planning process, and also how we want to develop a strategic and practical plan for this orderly coal phase down for China by implementing a more targeted retirement plan of a small set of plants that we define as the low-hanging fruit plants that can generate a larger environmental, economic, and social benefits by doing this early retirement. So this diagram, also you can see all of the charts I have in my presentation in this report. So we kind of divided our analysis into 2 major parts. The first step, we identify this the set of low-hanging fruit plants by doing first a comprehensive review of the existing policies on coal plant closure. We also look at additional available policies in the 14th and 15th five-year plan that have intersecting policy goals that are related to coal retirement, including the National Carbon Emissions Trading Scheme, the Clean Air Action Plan, also water conservation targets. And in step 2, we further quantify the benefit and a broader set of implications of the low-hanging fruit plant retirements, and we demonstrate the large benefits and small risks actually associated with this retirement. I'm not going to read all the text in this box, but it actually gives you the specific policy criteria we implemented under each of the policies mentioned for each of the periods. We also did additional adjustments to better reflect the local context, local priority. For example, we have the CHP plants in the northern provinces that are providing residential heating services. Those plants are excluded from this near-term low-hanging fruit retirement list. The bars on the right shows the identified low-hanging fruit capacity by each individual policy criteria independently. And then with the after the regional adjustment, the combined low-hanging fruit list are shown in the bottom bar. There are two important messages. The first one is the retirement are relatively evenly distributed between the two periods. We see 9% of existing today's 2020 capacity retirement for the 14th five-year plan period and 10% for the 15th five-year plan period. Also, interestingly, those retirement are actually driven by different policy goals. Mostly the 14th five-year plan retirement, the near-term retirement are motivated by the air quality goals, where the national carbon market, you can see the orange section are mostly driving the slightly later 15th five-year plan retirement. At the national level, we can, with all of these retirement plans, the total coal capacity is going to decline from today's about 1,100 gigawatt to 981 gigawatt by 2030. This also assumes the new plants at early stages are canceled beyond those already started construction or received the official approval. This is actually in line with the most recent notice from the National Energy Administration about, in principle, no new power-only coal plants are gonna be approved anymore. The targeted retirement, although representing 19% of the total capacity, we see in terms of number of generators, it represents a larger share, 35%, or over 1,000 units, because all of the plants we identified are smaller, older, also dirtier and less efficient. Representing, showing the individual plants we identified on these maps. You can also see, in addition to the relatively even distribution between the time period, the temporal distribution, we also see the spreads are relatively even across the different regions of the country. Summarizing all of the maps into the provincial level, we can see, compared to the more concentrated new builds in a few provinces, the retirement is more evenly spread out. Several provinces, including Shandong, Guizhou, Henan, Inner Mongolia, and Hebei provinces, provide the largest potential for this targeted retirement because of the feature of their existing plants. We also see another set of provinces like Jilin, Hainan, Shanghai, Shanxi, and Guizhou. Most of their retirement are going to happen in the 14th five-year plan, mostly because of the air pollution. The highly polluted units are located in those places. In terms of the percentage of capacity, the retirement actually exceed 50% in 3 provinces, including Qinghai, Yunnan, and Guizhou. And all of them actually have a high potential in renewable energies, and coal plants actually play a less important role in those regions. Although we didn't set up this kind of the geographic or distribution even as a criteria, the results actually shows the distribution is actually helps ensure that no region is overburdened by this early retirement. The second step of our analysis is to look at a set of benefits and risks associated with this retirement. On the benefit side, in all the cases, you can see the percentage of emission reduction and also water saving are larger than the percentage of capacity reduction. In other words, those plants are contributing, are making a larger impact in those negative impacts. So retiring them generating larger benefits. On the risk side, it's the you can see the opposite number actually. The strength in terms of stranded assets, it only represents about 6% of today's coal plants' total assets value, because those early retirement, targeted retirement plants are generally older. So by using the 30-year design lifetime, the stranded assets impacts are actually small. And job losses, just transition, I'm going to talk about it in more detail in my next slide. Looking at the power generation reduced from low-hanging fruit retirement, it represents 11% of 2020 total electricity. And to put that in the context, what we estimate from the new solar and wind deployment during this decade can actually provide over 2,100 kilowatt hour in 2030. Another note I forgot to mention in terms of the carbon emission reduction, it actually really helped China, the coal power sector, to reach the 1.5 degree range in 2030, where this one strategy can reduce the coal power generation carbon emission by 20%. An additional reduction can be achieved by other strategies like improving plant efficiency and lower utilization. So this strategy is actually very important for the 1.5 degree and China's carbon neutrality goal. Just want to zoom into a little bit with one example of this employment risk. I would encourage everyone to check out the report. We actually have very detailed kind of the implication, quantification for all of the metrics I showed in the table, since we have this plant by plant analysis. But just want to give one example on the job losses side. The total job losses we estimate nationwide is about 300,000 job losses. That represents about 33% of today's coal plant workers. This is a larger number compared to this 33% is a larger share compared to the 19% capacity reduction, because in China, the smaller older plants actually have a larger per megawatt employment. And you can see also the distribution between the two periods in terms of job losses and by the different plant size. We also look at the potential layoff in terms of their positions and also their skill sets. We can see the majority of them are currently doing OM jobs at the power plants and are relatively median and highly skilled workers, which have the potential to transfer to other positions in the growing renewable energy sector, But of course, there are challenges about providing reallocation support or retraining programs. Those definitely need complementary policies to address those challenges. We also zoom into, in addition to the national level, although it only accounts for 0.02% of the total labor force in China, some of the counties that are highly highly dependent on the local economy, highly surrounded by the coal power plants, may see a larger share of the job loss impacts. That can be about 2 or 3% of the total labor force in that county. And those counties are located in Inner Mongolia, Gansu, Hebei, Heilongjiang, and Shanxi. And we do have a county level map that people can check out in the report. So just to do the conclusion, our analysis demonstrates with this strategic and integrated planning process, China can start an orderly coal phase down with targeted retirement of a small set of low-hanging fruit plants. And this retirement can bring tangible benefits where the risks are manageable and are clearly outweighed by the benefits. And to meeting the growing demand for China within this decade, coupling this carefully structured retirement plan with an additional number of strategies, including feasible levels of accelerated renewable deployment, energy efficiency improvement, additional infrastructure, including transmission, storage, and cross-region load balancing, China can really enable this coal phase down within this decade. And for the national and subnational government to start implementing this plan, there are 3 steps we list out here, including conducting a plan level review at the more granular level to really identify this schedule. And the second, to combine this strategy with additional investment plans, support the other infrastructure and facilities. And the third is to providing the additional policy support to enable this transition to be a just one and address the impact for the highly impacted workers and communities. With that, that's the end of my presentation, and thank you. Happy to answer questions at the Q&A session.
Thank you so much for that wonderful overview of the report. Next, we'll hear from our 3 issue experts for their comments and perspectives. I will introduce them one by one. First, we'll hear from Dr. Yuan Jiahai. Dr. Yuan is a professor of management science with the School of Economics and Management at North China Electric Power University. Dr. Yuan's research interests focus on low carbon transition of China's power sector and coal power policy. We'll also hear from Dr. He Gang. He Gang is an assistant professor of energy policy in the Department of Technology and Society at Stony Brook University. Dr. Gang's work focuses on energy systems analysis, energy and climate policy, coal and power sectors, and their key role in both the global energy supply and in international policy frameworks. And finally, Dr. Zhang Ying is an associate researcher of the Research Institute of Eco-Civilization and deputy director of the Research Division of Sustainable Development Economics and director of the Natural Resource Asset Accounting Research Department of the Research Center of Sustainable Development at the Chinese Academy of Science. Her main research fields include sustainable development and climate change model research, quantitative economics, low carbon economic development, and environmental economics. I welcome our panelists. We're really thrilled to have you with us today. So I'll ask each of you to please give a few minutes of opening remarks, and then we'll turn to open the discussion. Dr. Yuan, the floor is yours.
Thanks, Jessica. It's my great honor to be here today to participate in this interesting seminar. So I want to start my comments with my observation on China's recent dynamics of coal-fired policy. Then I'll try to comment to position the report that Rena just delivered with China's policy framework. So as Rena has noted, that now we are greatly welcome that China are going to strictly control new coal power project during the 14th five-year plan and will not build new overseas coal power plants. But some recent changes in China's energy supply and especially power supply and demand over the last 2 years have, urged the central government to make some fine tune to China's coal power policy. So the recent announcement by NEA is that China will not build new coal-fired power plants for the simple purpose of electricity generation. I think we will wonder what is the behind this statement. We know that the coal power plants will certainly, the main purpose of building a new coal power plants was for power generation, but not simply for the purpose of electricity generation means that China will build new coal power plants only when there is serious resource adequacy issues, which means that to build new coal projects to provide firm capacity, and also because renewable penetration will take off in China. In the coming 5 years, the new annual installation of wind and solar capacity will be even larger than the past 5 years. So the flexibility issues of China's power system will be even prominent in the coming years. If we looking back, what happened in China's electricity supply and demand over the past 5 or 6 years, we can see that from 2016 to 2021, the total electricity growth was more than 2,700 terawatt hours, among which more than 1,000 terawatt hours is coming from electricity substitution. That became a national energy policy 5 years ago. And on the other hand, we can see that coal still accounted for more than 1,100 terawatt hours, accounting for some 45% of China's total growth of new demand growth. But if we look at what happened last year, the coal generation grew by more than 400 terawatt hours, and it was from the chart on the right, we can see that this figure actually marks the recent peak in annual coal power generation growth over the past decades. What happened is that, we also know that there is serious power shortage in China since the third quarter of the last year. If we take those power rationing and even blackout into consideration, coal power generation could grow by more than 550 terawatt hours. So this is the reason why that the Chinese central government will keep the supply security or energy security as the top priority over the next 5 years. And if we observe the new capacity expansion, we can see that the annual growth is actually on the declining with China's supply side reform policy that was delivered in the 13th five-year plan. But as Rena just noted, there's already 200 gigawatt new capacity and construction of in the early stage of planning. So it is, with the serious concern of supply adequacy. So there's no doubt that the new coal projects will continue to be built next in the next few years. So the question is, how can we try to stop the new build of that higher scale? I think the chart on the left can have some information behind. In the field, the electricity substitution in China should be driven by non-fossil power generation instead of coal power over the past and right now. And so the next 5 years, there will be a clear transition strategy for coal power in China. So for the new building, the new projects will only be built to support firm capacity and reliable renewable integration. And for the existing capacity, flexibility retrofit, heating supply retrofit, and also coal-firing retrofit will be delivered to make sure that while on the one hand, those existing capacity can contribute firm capacity and the flexibility for the power system. On the other hand, it can be less pollution emission, in particular, the less intensive in carbon dioxide emissions. And on another stream will be concentrate on those older and inefficient coal power plants. So for those substandard units, feasible retirement planning or strategy should be formulated and delivered in the coming years. So why that? I think the report just delivered by Rena is actually a very good report that fits into China's coal power policy well. But I also want to provide one point that deserves attention is that maybe not simply a shutdown policy will be feasible for China because of the resource adequacy concern. In some cases, life extension and strategic reserve policy retrofit could be used to make sure that fewer new coal power plants should be built, while on the other hand, resource adequacy issues can be addressed in this way. So if we're looking at the potential of retiring old and inefficient coal power plant, we can see that a total of nearly 70 gigawatt units will reach its design service life and can be subjected to long retirement. And then by the end of 2025, excluding this long retirement, there will be another 113 gigawatt coal units sized below 200 megawatt and below, and implying a big potential for retiring old and inefficient units. So life extension of qualified coal power units is crucial for the new power system for resource adequacy and supply security concern. And for another point that deserves attention is that with more small units becoming CHP units, it would be even difficult to retire it from China's power system because the heating supply is a matter of livelihood, and there are many barriers for the local government to simply shut them down. So which means that, according to my observation, we need a more detailed analysis by taking resource adequacy and heating supply issues into consideration to work out a maybe more feasible co-retirement strategy and policy for China. I think that could be a very interesting and important issue for the future work. So I will stop my comments here, and I'm ready for questions in the Q&A sessions. Jessica?
Hi, yeah, we're going to move now to Hegang's presentation, and then when all the presentations are done, we'll move to questions. So thank you very much for that presentation. It was very interesting. Hegang, please.
Sure. Thank you, Jessica, for the introduction. And let me start by congratulating Dr. Cui and the team for such an important and timely report. I also want to echo what Professor Yuan just shared, the dynamic challenging of the China's coal transition. The report lays down a groundbreak work to identify low-hanging fruit of coal plants for retirement, and it shows a feasible strategy to implement the coal phase down in China. This is very important. Both Jessica and Dr. Cui mentioned it's very important to do coal phase down and renewables at the same time. So I hope to add a few comments on renewables. You may be curious, we are talking about coal, why renewables? Here's the thing, it's good to phase down coal, but where our electricity comes from, the answer is non-fossil and especially renewables. The rationale is that the more we can provide secure renewable supply, the less we will rely on coal, and the better chance we will be successful to phase down coal. First, China's clean power transition needed two acceleration at the same time. While accelerating phasing down of coal, we are needed to accelerate renewable development and integration. Renewable will lead first feed all the new demands and then to replace coal. Let's be real. Coal generation is still growing, as you also seen from what Professor Yuan shared. And good news is the share of renewables also grows. In 2021, coal accounts about 62% of the total generation, hydro about 16%, nuclear 5%, wind 8%, and solar 4%. Renewables, including hydro, wind, and solar, overtook coal in new capacity. This chart shows the capacity addition in each year. And as you can see here, renewables overtook coal in new capacity in 2013, and renewables combined exceeded 50% of the new capacity in 2016. And in 2021, 78 of the new capacity are renewables. According to the latest data from National Energy Administration, by the end of 2021, both wind and solar capacity exceeded 300. For wind is 328 gigawatt and solar 306 gigawatt. To achieve carbon neutrality goals, we need 10 times today's solar and wind capacity by mid-century. That's the scale of acceleration we are talking here. Second, the good news is cheap renewables are available, and it's a game changer a renewable dominant path is not just technically feasible, but are also cost effective and with water saving and other benefits. This chart from World in Data shows from 2009 to 2019, the cost of PV fell by 90%, onshore wind by about 70%, and concentrated solar by 60%. The loading rates of PV reaches 36% and 23% for onshore wind, meaning that any doubling communicative capacity was installed PV, its cost will fell by 36%, and for wind 23%. 2021 can be seen as a tipping point for solar, wind, or renewables grid parity to achieve grid parity, or what we call low cost renewable era. In China, the National Energy Administration, or the National Development and Reform Commission, announced the cancel of subsidized power tariff for new central PV and onshore wind in 2021. And that means renewables are achieving grid parity, and that's a milestone for renewable development. The arrival of a grid parity relative to the 2000 forecast about 50 years ahead of time, and relative to the 2010 forecast about 30 years ahead of time, and relative to the 2015 forecast about 10 years ahead of time. So the early arrival of a grid parity for renewables really accelerates the development of a renewable, and also opens new possibilities for achieving carbon neutrality by mid-century. In a collaborative Nature Communications paper with Lawrence Berkeley National Laboratory, we found that if the current trend of declining renewables costs continues, by 2030, wind and solar could provide 39% of electricity generation. Together with hydro and nuclear, the share of non-fossil electricity could be 62% in China by 2030, compared to 50% commonly discussed. What's more, it will be 11% cheaper than in the reference scenario. So wind and solar together could exceed 1,800 gigawatt of capacity, compared to the 1,200 gigawatt capacity as in the national goal. In another collaborative paper with Tongji University, we found that cheap renewable reduce the need for carbon capture and sequestration by 80% in 2050, and saves water consumption for cooling by about 10 billion cubic meters annually compared to the reference scenario. Those are the benefits, and especially we may not rely on CCS to achieve our carbon neutrality goals. Third, coal could play a facilitator's role in integrating renewables. This is also noted in Professor Yuan's remarks. Coal needs to reposition and repurpose itself from cornerstone of the energy to stepstone in the clean energy transition. Flexibility, retrofit, and converting coal plants to reserved capacity could help us to address the flexibility challenges in the renewable dominant grid. Even though coal flexibility contributions to renewable integration is marginal compared to building national electricity market and dispersed renewable investments, according to a collaborative paper with Lawrence Berkeley National Laboratory recently published in iScience. In summary, for my notes, accelerating coal transition and renewable development needs to go hand in hand. And the renewable achieving grid parity not just make renewables technically feasible, but also economic competitive. And coal could reposition and repurpose itself from cornerstone to stepstone of China's power transition. I'll stop here, and I look forward to more discuss more in the Q&A session. Thank you.
Okay, it's my turn, and I think it's my turn. Thank you for the chair, and thanks to the organizer to hold the meeting. It is my pleasure to join this discussion and see many friends here. I'm so happy to see that Dr. Cui and her team has provided us such a comprehensive and timely report on China's coal power sector decarbonization. As we all know, power sector is one of the most important sector to achieve China's carbon peak and carbon neutrality targets. The transition from coal power generation to clean new renewable energy is the key to achieve such ambitious target. I believe that Professor Yuan and Professor He are both experts of power and energy sector. I totally agree their comments from the technological perspective and the policy trend. And I will try to share with you some of my ideas from the social cost for this necessary and inevitable coal phase out process. Transitioning rapidly away from coal and other fossil fuel relevant industrial will present social justice issues, particularly concerning the potentially precipitous elimination of relevant jobs. I'm glad to see that in this report, it already presents a quite comprehensive analysis of relevant benefits and the risk of such transition, including the employment effect analysis. I read from the report and the slides, it showed that the estimated job losses from the research is around about 300,000 by 2030. And the research team thought it is affordable at the national level. I've also read from the Q&A board that someone put forward the question about the job creation effect from the new renewable sector. Could it offset the job loss in the traditional coal power sector? And I agree that from the data, the renewable sector should be more labor intensive than the fossil fuels. But I hope it could be more careful on such conclusion, because such energy transition, because since the economic final out from COVID-19 took a very serious toll on China's employment situation, this kind of energy transition will impose extra pressure on fossil fuel industry and the power sector itself here. And I believe that this kind of a job issue is not a simple calculation of job creation and job loss, because we need to consider that there could be several mismatches between job loss and job creation. As for the power sector, I think we need to think of the time mismatch and the space mismatch. That means although the emergent renewable energy development, as it already showed by Professor He's slide, is expected to compensate for the unavoidable job losses in carbon-intensive activities at the level of the whole economy. but these jobs will not necessarily appear at the same time and in the same place where jobs are being lost. The creation of renewable relevant jobs may take time with some necessary training, while the job losses from the coal phase out could be more immediately. Concerning the space mismatch from the report, we could see that the region distribution of such job effect if we phase out the coal power gradually, most in coal-dependent provinces, which could be lack of renewable energy resources, and the solar energy manufacturing industrial here in China, mainly located in Changjiang Delta area, while the wind power manufacturing industrial mainly concentrated in Beijing, Tianjin, and Hebei area. So the job creation effect could not perfectly match those job loss and where there is urgent need for the new job. Thus, we could not count on the total job creation could help to solve the problem of the impacted regions or communities described here. In the report, it already identifies several hotspot counties as I read it in the review process. If the project could continue, I hope it will make several case studies on these areas to find out the best practices to help the impacted worker group to find alternative jobs. Unlike the coal mining industry, which myself tracked for several years, within this power sector, I think a good trend is group of employees facing higher level of risk are those working on the operation and maintenance of coal plants and have relatively high skill levels, as we could also see from the slides before. This could be a quite significant advantage for the group to find new jobs, but I believe the necessary and appropriate training is still needed. Tackling these structural mismatches should be one of the aims of properly designed just transition policies to balance the burdens of the necessary transformation. This is why appropriate and specific just transition policies tailored to the coal intensive region will become very crucial in facing these challenges. Just transition is not a new concept in climate change relevant research area. However, in China, it has not been integrated into the comprehensive policy framework. We all know that from the international perspective, the EU, US, Australia, and South Africa, as well as many other countries or regions have already taken some steps to design a framework to integrate such just a transition part into the energy transition policies, and also taken some measures to support that. But China has not established a similar mechanism yet. The lack of corresponding policies focusing on such areas would make the outward create some doubts on China's determination to phase out coal as it declared. And I'm also glad to see that in this report, it put forward the lead of such kind of just transition. As we see that China's leading group of carbon peak and carbon neutrality made its debut and announced a major strategy decision in last July. There are more than 10 ministry or department attended the very important first meeting, while the Ministry of Human Resources and Social Security, which is responsible for the employment policies, is absent from this important meeting. There is also no specific policy focusing on the impact of measure to deal with this kind of energy transition on employment. So we are working on that. We are trying to persuade the Chinese government to take consideration of this important perspective and try to establish a complete framework to help those impacted group to find new job. Although several studies has discussed the allocation of workers in China's fossil fuel industry, I think that few research has evaluated the reallocation process through the lens of the concept of just transition. And this report put forward it directly. I'm quite welcome this outcome. And I'm also looking forward that if the research could go on, it could put forward more concrete measures to help this coal power sector when it's phased out or the retirement, how could it help the impacted worker to find new job. Moreover, I think most research currently have ignored the perspective of worker group itself. The research on the most vulnerable industry and region is urgently needed to help policymakers appropriately assess the situation and design suitable mechanism. I believe this research has already presented us a quite clear picture of coal sector, and I with my group also working on to identify the real situation in the coal mining sector. And I also see that in China, there are other groups focusing on the employment effect and just transition lead, like the transition from the traditional petrol-driven car to the electric vehicles. So I think in the future, this kind of research will be more and more, and forward-looking policies that actively manage the transition are very quite vital to the success. Losing time by trying to maintain the status quo will only make the effect worse and increase the cost of the transformation. Besides, I think this kind of discussion is very important because we need to share experiences with other countries facing similar challenges and find the best way to help impacted worker and community here in China to adapt this in inevitable adjustment, which could be very fundamental for this kind of phase out to achieve its desired result. That's all. And any question is welcome in the Q&A part. Thank you.
Thank you so much, all of you, for sharing those remarks. It's really interesting to hear about the trends in coal and renewable energy planning, and also the spatial and social implications of China's energy transition. So we're at time, but I'd like to ask everyone to just stay for a few more minutes for some questions. I know our panelists have also been answering questions in the chat, which has been great. So if you have any questions, we invite you to please type them into the Q&A box at the base of your screen, and we'll try to do a couple in our last few minutes. So one question is focused kind of specifically in the methodology of the report, and the question is, the current power liberalization also helps with the retirement of low effective power plants. Has this effect been estimated in the research? And that's for you, Dr. Cui.
Yeah, thank you for the question. That's a really great one. I think we mentioned kind of this retirement strategy is going to be coupled with a number of complementary strategy in the power system, including the power market reform to better help doing the cross-region balancing and cross-region planning that will really contribute to this entire power system transition. We do not include a specific scenario or kind of having that factor in the strategy or in the action plan we developed in this report. But that I agree, that's a really important pieces that we should kind of look into further in future research. Yeah, I want to say like many great questions in the Q&A box, and I think all of us has been answer those, and happy to follow up. I know some of the I don't have the data at handy right now, but happy to follow up offline as well.
Great. Just, I guess, a question to just have everybody weigh in on at the end here is that, as Dr. Cui mentioned in the report, we show how certain provinces have the highest potential for these targeted retirements. And we now have brought up many issues today, thinking about jobs and renewable energy, and also just balancing wider needs in China's economy. And so just curious if the panelists have seen any changes in any provinces that seem to be moving faster on this coal retirements, given these other issues that are at hand. And if you have, if you know what has been driving that change. Welcome thoughts from anyone.
Yeah, I think for one province like Qinghai province, it already has, some 80% or more than 80% of power supply from renewables. And there was only some less than 3 gigawatt old coal units in operation, and its operation is mainly to provide a stability service for the power grid, not simply for power generation. So I think province like Qinghai can be a pilot in China to fully retiring its coal units on province level. And also we can see that with the implementation of China's dual carbon policy, there will be even strict requirement on local government to deliver more renewables and to have more share of non-coal use in their primary energy consumption share. So which means that in the future, province with high pressure to integrate more renewables will have to reconsider the role of coal in their power supply mix. And in this way, there could be, create a pressure for those provinces to moving on faster than could be. Yeah.
I just add a few notes on probably Inner Mongolia is a very interesting, as we discussed here. It has rich coal resources, it has rich renewable resources. It presents a very interesting bet to see how these two are dynamic and compete with each other, and with competing conflicts and implications. I see Inner Mongolia as a very interesting province to observe.
Yeah, I also want to agree with both Yuan Jiahai, Professor Yuan, and Professor He. I think the provincial story is very interesting and more complicated to explore. And with a lot of the resources are, you can see are both concentrated in a few key provinces, both on the fossil side, on the renewable side, as Professor He mentioned. And I think it's with the competition, it's going to we're gonna see the curtailment of renewable declining. But with that regard, it's like a coal plants keep lowering utilization to support the renewable generation, which I think is getting more getting the renewable curtailment controlled has been a priority for Chinese policy. But at the same time, I think coal plants will require additional investment on the flexibility retrofit to be able to operate at that level to support the renewable. I think one consideration in this strategy is we don't want to put additional investment for the plant we identified because they have poor performance both in terms of environmental results or the economic results. So I think even with the grid stability consideration, like a retrofitting possibility, I think those plants are not suitable for that. But then the kind of a planning across the country with different region characteristic contributing differently to the power system will be really important in the next few year or decade to figure out for China.
Yeah, thank you so much. Those are all great points and good things for us to think about. Professor Zhang, I just wanted to give you maybe the last word if you have something to add about this is a question that's come in the chat, thinking about how subnational governments are responding to just transitions and in thinking about provinces that need to move off of coal. Wondering if you have any final thoughts.
Okay, thank you for some question because time limit, I could not answer it in detail. And I believe that one question is concerning the difference between the Chinese just transition with those from the EU and the US perspective. As I already described in my introduction, that in China, there is currently not just a transition policy mechanism. That is what we are striving for. We try to show the policymaker that what is going on outside of China and what they do. We already discussed with our EU peers several times, and I saw they had made a very significant progress because they has included just transition mechanism into its Green New Deal framework. It will collect fund to help those regions or groups to better adapt to such kind of change or transition. And we hope that for China, it could try to establish similar fund, because as we already discussed today, this kind of job effect is not evenly across all the country. Some of the regions or communities suffer more compared with the majority of the country. So we should take measures to help them. And so there is a question about the local government. And I have long time research on the Shanxi province because it's one of the China's largest coal producing provinces. It possesses approximately 1/3 of China's total coal deposit, and as the data shows that more than 1/4 of China's coal workers are located in Shanxi. We know that Shanxi government is urgent for the policy to help them to experience or to to go through this kind of transition. However, just depend on itself, it could not collect enough money for that. So we hope that we will discuss with them and also with the central government to see that what could be the appropriate policies to help them, like to collect money or to give some policy preferable policies for them to establish such kind of alternative industrial, also maybe some more preferable policies to help them to develop its educational, to help all the students there to equipment them better skills and knowledge to like to find new job in other industrial. Yeah. Okay.
Thank you so much, Professor Zhang. I just want to close us out here and thank each of our panelists and our audience for joining us today. We really appreciate your time and your participation in this discussion. There are some great questions. I'd also like to just take a moment to thank all the authors and staff from both organizations that were involved in the report research, writing, and production, and also in producing this event tonight. It's really been a pleasure to be part of this collaboration. This event has been recorded and will be available later on the California China Climate Institute's website and YouTube channel. Thank you everyone for joining us, and thanks for your patience as we went a little over tonight. Have a wonderful night and a wonderful day. Thanks.
Thank you.
Yes, Jessica.
Thank you, Jessica. Thank you, everyone.
See you next time.
Bye.
Bye.